I built this little turret which has a camera and can be controlled remotely via this web interface. This little computer hosts an entire web page. My PC just loads it and sends commands using HTTP. I don't want this. I want the PC to be the host server and the microcontroller to be the client. This just needs to take and send photos. The relationship needs to be reversed. I wanted to communicate with the ESP32 using custom C code that would send out commands from the computer to the remote card. I instantiated a config struct on the microcontroller that's updated whenever it receives these commands. How does it receive the commands? Through the internet. At least my intranet, or my Wi-Fi. I use TCP. The ESP32 has a Wi-Fi class and some examples, so I started off using that and just the netcat or nc command in the terminal. This was pretty straightforward, just some string parsing on the microprocessor. Going from the terminal to custom code took some learning about sockets and files, Unix files. See, in the context of C and Unix, a file is so much more than something applications use to store data. A file serves as the interface, the staging area for your data between the application and the operating system's underlying kernel. You certainly can use the standard input to read what the user types, and you can output everything to a text file, but the real power lies in the less standard files, because all input and output is done by reading or writing them. What is a socket? A socket is a file. To be a bit pedantic, a socket is a way to speak to other programs using standard Unix file descriptors, a file descriptor being an integer associated with an open file. You can use the socket system routine to get the file, and while you could use read and write calls to communicate with it, it's much better to just use send and receive. I'm using a stream socket, which uses the Transmission Control Protocol, TCP, to guarantee the data arrives in the same order it was transmitted. Another popular option is UDP, User Datagram Protocol. It's less guaranteed, but better for transmitting to several destinations at once. Anyways, use socket to get the socket file descriptor, these structs to define the IP and ports of both the server and the client, and then these calls to bind to the port and connect to the client's connection request. Accept the client's connection request. After that, it's mostly control flow stuff, and actually taking the photo. The benefit of Arduino and the ESP32 is that they're so ubiquitous at this point that there's a reference example for basically anything you would want to do. So I can look those up and use that to help set up the camera, call the functions to take the photo and load it into a struct, which holds some metadata and contains a buffer for the actual image. I should note that while the source code supports RGB image types, the ESP32 doesn't actually have enough flash storage to fit the entire RGB 888 or RGB 464 onto it. So we're sticking with the compressed JPEG format. For the time being, I'm taking the buffered image data and storing it as a file using SPIFs, SPIFFS, or SPI flash file system, which emulates a single-layer file system on the microcontroller's flash memory, though this might not be the best in terms of longevity for the IC. So I send command 4 to take a picture and command 5 to send it, and nice. You can see the data stream here, which isn't great, so I modified the server to just dump it all into a JPEG file. Unfortunately, this didn't produce a usable JPEG file. It couldn't be processed. So I sat down and hashed out a rudimentary transfer protocol on top of TCP. It's not great, it's inefficient, but I still don't fully understand this stuff, so it's a start. Essentially, I just divide the image up into chunks, send it out, and wait for a response. And then I send the next chunk. It's slow, but it worked. I could increase the speed a bit by increasing the chunk size, but beyond a certain point I just got junk. So this will definitely have to be replaced and optimized if I want to use it for anything. I thought it would be nice to wrap this image up into a GUI, so I compiled the raylib source code, grabbed the ray GUI header, and made a few buttons to send commands out the back end. Oh, and Raylib, for some reason, doesn't support JPEGs unless you uncomment this line, and then it just works fine. And there you go. It's a bit underwhelming, but for my first time working with sockets, it's not too bad.